RISACalc is a web-based application for individual component design, which provides engineers with an easy-to-use interface that allows for full control over inputs such as geometry and loading, in addition to graphical and numerical results, including robust detailed reports. In this video, we'll take a look at the steel joist design functionality in RISACalc. In this project, I've already added a joist, and before we go ahead and look at any of the general or design properties, I'm going to go ahead and click on the gear, and we can see the two steel joist codes that are available to us, the SJI 42nd edition and the SJI 43rd/44th edition. We're going to go ahead and keep this most recent code and click apply. Next, we can see we have two shape options here. One, that we can either explicitly define our joist shape, and the second is we can choose to optimize our shape. The optimization will pick the least weight joist based on the length defined and also the load applied. Now we can also choose to enable this filter by length. The filter by length option reduces the list of available members such that only joists whose max span length referenced in the SGI load tables exceed the specified member length. So if I go ahead and set our member length here to 20 feet, we can see that our shape list has changed to only show us shapes that could even possibly work based on that max span length. I'm going to go ahead and start by choosing a 16K5. Now we could also choose different joist series, so K series, LH, DLH, and also KCS series joist. In this case, we're going to just focus on K series. Next, if I go ahead and click the design tab, I can see I can select the deflection ratios for dead live and dead plus live as well. Finally, I'm going to go ahead to loads, and here I can add point and distributed loads. So I'm going to start in this particular case by adding some distributed loads. So let's first add a distributed load for dead load. So I'm going to add a magnitude of 250 pounds a linear foot, and we'll make it category dead, and we're going to apply it to the entire beam. Next, I can go ahead and add a second distributed load. In this case, let's go ahead and add 275 pounds a linear foot, and let's make this a live load. And again, we'll apply this to the entire length. Now, all the while we're adding loads, we can see that the load combinations are automatically being created for us. One other thing to note here is that the self weight is automatically included in the definition of the joist, so you don't have to add that in addition with your dead load. Now, when we're ready to go ahead and check this member, we can go ahead and click the check mark to toggle on the unity check, and we'll get ourselves our code check as well as our initial design results. And so in this case, we can see our code check at 97% utilized. If I go ahead and minimize the detailed report, we can see our moment diagram, we can turn on our shear diagram, our deflection plot, and then even our reactions. Now, if I go ahead and expand the detailed report, under the properties here, we can see the basic information of the joist. If we scroll down a little bit, we can go ahead and look at the calculations tab, which shows us the load capacity check, so the required based on our applied load and the available, and finally the deflection check. Now, before moving on, I'm going to go ahead and open up this joist I already have pre-created here, which is basically the same type of joist, except in this case, we've chosen to optimize that joist. So instead of setting a explicit shape, we define the joist series that we wanted to define with and the length. Now, if we go ahead and look at the properties here, we can see it's chosen a shape for us. So it's chosen that 16K2. And we can also see in the calculations here that it's done the calculation based on the required and the available capacity. Now, typical joists are designed when you have uniform loading, but what happens when we don't have uniform loading? So in this case, I'm going to go ahead and add a new joist, and we'll go ahead and choose it as an explicit joist, and we'll set the length here again to 20 feet, and I'm going to choose the shape, in this case, to be an 18K5. Now, we'll leave the design criteria the same, but let's go to loads in this case, and I'm going to start by adding a point load. So let's add a 750 pound point load in live load at the 7.5 foot location. Next, let's go ahead and add a distributed load, but instead of a uniformly distributed load, let's go ahead and add a tapered distributed load. So I'm going to add this load from 350 pounds to 250 pounds a linear foot, and we'll add that in the dead load category. So again, our load combinations are getting created for us. And if we go ahead and toggle on the unity check for this member, we can first see the code check. So we're, again, getting a passing code check. We can see all of our diagrams. So our deflection plot, our shear diagram, our moment diagram. But then if we go ahead and look at our detailed report, the first thing we'll see here in the properties for the input data is the shape defined as an 18K5 SP. So as a result of the addition of this tapered uniform load as well as the point load, we're designing a special joist. Because the loads are not uniform, RISACalc is actually going to calculate an equivalent distributed load for us. So if I click on the Loads tab, we can see here we have equivalent distributed loads for dead load and live load. So based on the dead load, we have a start and an end magnitude, and then based on the applied live load for the point load, we have a start and an end magnitude. This summation of equivalent distributed loads is what's going to be used in the calculations here. So that is that required amount compared to the available capacity of that 18K5. Now, if we wanted to go ahead and print this report, we can go ahead and click the download button. The report will generate, and then we can go ahead and open that PDF in Bluebeam or in whatever PDF viewer that you're using. For more information about RISACalc, including pricing, please visit risa.com.